Okay, so germanium is proof that the periodic table is more than just a chart. It's actually a map that can predict the existence and the properties of elements before we discover them. So this is a group 14 element beneath carbon and silicon in the periodic table. Its atomic number 32, and its atomic mass is 72.63 grams per mole. It has 4 valence electrons, just like carbon and silicon, and so that gives it the following electron configuration right here. And in 1871, Mendeleev predicted the existence of an unknown element that he called eka-silicon, based on gaps in his periodic table. And so when germanium was discovered in 1886 by Clemens Winkler at Freiburg University, its properties very closely matched his predictions. And so this was a major confirmation of the power of the periodic table. So he named his new element germanium after the Latin word Germania for Germany. He originally wanted to call it neptunium, but discovered the name had already been proposed for an erroneous claim of a discovery years prior. And so the name neptunium would ultimately go to atomic number 93 in 1940. Different story. So germanium was first isolated in a mineral called argyrodite, and so that also contains silver and sulfur, and it's relatively rare in the Earth's crust. It's usually obtained as a byproduct of processing zinc ores as well as coal ash, rather than mined as a primary element. And so germanium helped to launch the semiconductor revolution, which is important in things like this iPad here, right? And so it's one of the first materials used to make transistors. And so the first practical transistor was developed in 1947 by Bell Labs. And they used germanium first before silicon became the dominant semiconductor that's used today. And so what a semiconductor is, what that means, it can conduct electricity better than an insulator, but not quite as well as a metal. Its conductivity can be precisely controlled by adding tiny amounts of impurities in a process called doping. And so germanium is also used in space. Some early solar cells in specialized space technologies actually use germanium substrates because of its excellent electronic and optical properties. And so it also helps us to see invisible light, such as transparent infrared radiation.